Alright, so we'll start off this week by looking at section 4.4, which is on finding area of a triangle. Alright, so what I've started out with here is I've got a diagram. I've labeled a couple of the sides. Normally we label all the sides A, B, and C. I'm not going to need the third side. That's why I didn't label it. So if you were just kind of starting out with that diagram, you could just label sides A and B. Side C would be the side that's over here, and we always put gamma across from C. So that's why I labeled that angle gamma. Then what I did is I drew a perpendicular line straight down from the vertex at the top to the bottom. Okay, any questions on that picture? All right, and what I want to do is I want to figure out the area of that triangle. All right. Now it's not going to have any numbers, so we're just going to come up with a formula. What's the formula that you normally use in geometry to find area of a triangle? Yep.
Half. Area equals half base times height.
Yeah. Area equals 1/2 the base times the height. So B is base, H is height. Now, that formula works fine as long as you know those two things. If they give you the base and they give you the height, you're good. Good to go. If they don't give you the base and the height, well, you indirectly have to figure one of them out. Right? And that's where the trig part will come in. All right, so if you have a triangle and you don't know the height, we're going to have to use a different formula. So that's what we're going to come up with right now. I'm going to make it a little smaller so we can see the diagram up above. Take a look. I want to try to find H. Okay? Let's pretend that you were given A, B, and that. All right. So it's like you're given three things. Right? And what we can do is just kind of look at it like that. If I just look at that part on the left, right? I've got a right triangle. All right, so maybe we can somehow use that to figure something out. What's the name of the side that's labeled H? From the perspective of gamma, would it be opposite, adjacent, or hypotenuse? It's opposite. And what about the side that's labeled A? Yep. Hypotenuse. So what trig function out of sine, cosine, and tangent has those two sides in it? Sine. So we're going to set up a formula to find the height. All right. So we're pretending like we don't know the height. We're going to find the height. So the sine, let's just write it down. The sine of my angle, sine of gamma, equals opposite over hypotenuse. So Joe, what would that be in this case? What's opposite and what's hypotenuse?
H over A.
Perfect. H over A. All right, make that a little bigger. All right, so I got that part. Now I said I want a formula for H. So I want to put the A on the other side. And Christian, how would I move the A over to the other side?
Would you multiply?
Yep. Multiply each side by A. And there's a formula for the height. The height is A sine gamma. Right. Now what we're going to do is we're going to take the original formula we had, and instead of writing H, instead of writing what I just put a box around, you can plug in what we just figured out. Okay. H is equal to A sine gamma. So now, instead of having the height, if they give you an angle and they give you one of the other sides, like A, you can figure out the height. And that's our new formula. So I'm going to plug in, actually I already wrote it up above, plug in A sine gamma for H, right there. All right, so what that gives me is 1/2 stays right where it is, the B stays right where it is, and instead of H, I put A sine gamma. So what's in parentheses there, that's my H. Now, that's all multiplied together. 1/2 times B times A times sine gamma. What they usually do is, since it's all multiplied, you can change the order, like 6 times 4, 4 times 6, same thing. They usually put the letters in alphabetical order. So they usually write it as 1/2 AB sine gamma. Now I want to go back up and look at the diagram for 1 second, because you can write this formula different ways. But I want to see if we can figure out what's the pattern there. So no matter which way you write it, they all have the 1/2. Okay, that 1/2 comes from the area formula. But let's look at the two sides and the relationship to the angle. They're all going to have sine in them too, right? But the sides can be different and the angle can be different. So we have A, B, and gamma. So if we go back up, where is gamma located if you compare it to sides A and B? Yep. In between them. And that's the pattern. So in general, it's always 1/2 the product of two sides, any two, times the sine of the angle that's between them. So let's draw that picture again down here and see if we can figure it out. So that would be gamma. What's the angle that's always across from A? The Greek letter we use? Alpha. And across from B? Beta. All right, so we've already done the A, the B, and the angle between them, which is gamma. Anyone think they can give me a different version of that formula using two other sides besides A and B? You're looking for two sides and an angle between them. That's the pattern. Yep.
B and C and an alpha.
Yep. So there is going to be a formula with a B, a C, and an alpha. Can you tell me what it would be?
It would be 1/2 B times C sine of alpha.
Yep, exactly. I don't know if that's the next one I wrote. Yep, that is the next one. 1/2 BC sine alpha. Again, 1/2 the product of two sides times the sine of the angle that's between the sides. And there's one more way you can write it using the last two sides we haven't used yet. What would be the last version, Joe?
1/2 AB AC sine beta.
Yep, 1/2 AC sine beta. All right. So that's not three different formulas, it's just the same formula written in three different ways. So what you want to really remember is this. So in general, the area of a triangle is half the product of the two sides times the sine of the angle between them. So it's another simple formula. Works very well if you don't know the height of a triangle and you have to find the area. Technically, you are finding the height using this. You're using right triangle trig. That's where the sine comes in. And you are finding the height. It's just kind of built right into the formula for you. So there's two formulas we're going to look at today. This is one. The other one is going to be helpful if you don't know any angles, but you know all the sides in the triangle. When we get to that one's a little harder to prove where it comes from. So we're not going to go through the proof of that one like we did this one. Okay. Any questions on that idea? Let's take a a look at some examples. Right, so it says find the area. Well, first, let's make sure that they gave me the right information. All right, so if I sketch it out, I've got A, B, C would be over here, and gamma would be across from it. So that's where the angle would go. Did they give me the right information here to be able to use the formula we just came up with? Joe? Yep, we got the right formula. Okay, let's see, you don't have to give me the answer yet, but Derek, can you just tell me what the formula would be that I would type into my calculator?
1/2.
Not sure? Yeah, Christian?
Would it be 1/2 8 times 6? Or
Keep going.
and then instead of h, it would be the sine gamma,
Sine gamma, which in this case would be,
sine 30.
yep, so it's 1/2 the product of the two sides times the sine of the angle between them. And the reason it's important to kind of remember it like that is because eventually you might have an example where you don't know which side is which. I don't know which side is A, B, and C here. So as long as I understand the general formula, it doesn't matter which side is really which. Right. So 1/2, 8 times 6 times sine 30. All right, let's multiply everything in front first. Eric, half of 8 gives me 4 times 6.
24.
So 24 sine 30. And now at this point, if you don't know what sine 30 is, we got to type it in. But sine of 30 does come out to a nice number. Comes out to 1/2. So it ends up being 24 times 1/2, which is 12. Now, that's 12. I want to keep in mind what we just did in that problem. It's because I got to put a label on that.
Oh, I was just gonna ask that,
Mm-hmm.
but you just said, well, if you put a label on it.
Yep, we should put a label on it. What does the 12 represent again? It's an
Area.
It's an area. Now, I don't know if these are inches or feet or centimeters, but I know that area is always square, right? So what I'm going to do is I'm just going to put 12 square units. If I knew it was inches, I'd put it square inches. If it was feet, put square feet. Okay, so you always want to make sure you put a label on it. That's it. So we just found the area of a triangle that we didn't know the height. We need 2 of the sides and 1 of the angles. Questions on that one? All right, let's try this one. So another one, find the area. Now if we look at it, we don't know the height. The height would be something like right there. This is kind of turned. That dotted line would be the height of the triangle. We don't know that. But we don't need to. We can use that other formula that we learned. Dylan, can you set up this one to find the area of the triangle?
A equals 1/2 3 times 4 sine of 30.
So sine of 30. It's not always going to be 30. I just picked 30 a couple times because 30 gives you a nice answer. All right, so we go through it. Corey, I get 3 times 4 is 12, and then half of 12? 6. And then we know sine of 30, what does that come out to again? A half? So the area of this triangle is 3 square units. Any questions on that? All right, let's try this one. So now the angle is 20.
Wait, why would it be units? Wouldn't it be inches?
Oh, did it say inches?
Yeah.
Yeah.
Oh, yes, thank you. Yeah, would be inches. Yeah. So if they give you a specific unit,
Yeah.
then you put that unit. Yep, thank you. Now the next one is back to no units. So when we do this one, we won't have it. And this time they said to find the area but round to 2 decimal places. That's because when you take the sine of 20, it's not a nice number. Okay, so let's set it up, find the area. Again, I don't know which side is A, which side is B, and which side is C. So if I go back at my different versions of the formula, which one am I using? I have no idea. I'm not really using a version of the formula. I'm using this concept. That's what I'm doing. Okay, so we'll set it up. Mike, can you set that one up for me to find the area?
1/2 times 2 times 5 sine of 20.
Yep. And if you want to do what's in front first, I mean, you can. Half of 2 is 1, so that cancels out. So all you're left with is 5 times the sine of 20. So 5 sine 20. And they said round to 2 decimal places, so if I round that properly, what would my answer be? Joe?
1.7.
Yeah, go ahead.
1.71.
Yep, 1.71. And what about the label on this one?
Unit squared.
Yep. Unit squared. Okay, any questions on that one? Yep.
Was that times 5?
Did I put in the time? Yeah, I put in the times 5. Yep. Yep, always make sure you type it in, right? Any other questions on that? Okay, so that's one way we can find the area. Half the product of the 2 sides times the sine of the angle between them. Now, let's look at what happens. We're still going to try to use the same formula, but this time they're going to give me all the sides. So let's find the area of this one. You don't need any new formula to do that one, even though they're giving you different information. Now let's check and see if we can just use the regular old formula for area of a triangle from geometry. 1/2 base times height. Do I know the base here?
Yes.
Yep, I got the base. Do I know the height? No. The height would be a line that goes straight up. So the height, like if you were standing right here and you drop something, that's the height. I don't know that. So you can't use 1/2 base times height. All right, so let's look at our other formula we got. We need 2 sides, right? Do we have 2 sides here? Yep, and an angle between them. Do we have that? No, I don't have an angle between them. So what do you think I have to do first here? Let's use the new formula we learned today. What do I have to find? I have to find an angle. Yep. All right. How am I going to find an angle there? I know all 3 sides. We did this, I don't think it was the last unit we did, it might have been the one before it. How do you find one of the sides there? One of the angles. Oscar, you remember? Yeah.
Inverse?
Yep, we're going to have to use inverse trig function eventually. But before I get to that, I need a formula that has a regular trig function in it, and then I can use an inverse trig function to solve it. So anyone remember the name of what we did to solve when we solved triangles? There's a special formula we have. It helps us to find an angle. Yeah? Close. Very close. Law of cosines. So when you have a side-side-side, SSS triangle, you can use the law of cosines to find one of the angles. Doesn't matter which angle. We can find any angle we want. So I'll let, how about Derek, why don't you pick an angle and just describe to me which one and we'll solve for it.
Alpha.
Alpha. So he's talking about the one right there. It's the one across from A. All right, so remember the law of cosines. It looks kind of like the Pythagorean theorem. One sine squared equals the sum of the other two. Okay, so I'll start us off with that. So one side squared equals the sum of the other two. And the reason I started with A is because Derek said alpha. Always start with the side across from the angle you want to find. So A squared equals C squared, or B squared plus C squared, minus. Now something comes after that. What comes after the minus? Yep.
2, 5 times 4.
Yep. 2 times 5 times 4
Times the cosine of alpha.
times the cosine of alpha. So now we have a trig function with an angle inside it we don't know. Mike already mentioned at the very end how we're going to have to solve it. We've got to use inverse trig. So but let's simplify first. So 64. 25 plus 16 gives me...
36.
25 plus 11 would be 36.
41.
41, yeah. So 41 minus 40. 2 times 5 is 10, times 4 is 40. Cosine alpha. Okay, and this is the part we got to be a little careful. I have 3 things left to do. What would be my next step?
Minus the 41.
Yep.
On both sides.
Minus the 41. That's gone. 61 minus 41 gives me...
But 64.
Oh yeah, 64 minus 41 gives me 23. And that's negative 40 cosine alpha. Now 2 steps left.
Divide by negative 40.
Yep, divide by negative 40. Negative's gone, the 40's gone. All right, 1 step left. I got to get rid of cosine.
Inverse cosine?
Yep, inverse cosine. So take the inverse cosine of each side. And there is our angle. So let's see what we get for an angle. So second, inverse cosine, negative 23 over 40. And our angle, the one that Derek wanted to find, is 125 it's pretty close to 125.1. So let's call it that. So this angle, just erase that. 125.1. Now I'm good. Now I can do exactly what we've been doing the whole time. So Justin, can you set up my formula to find the area of this triangle?
Yeah. 1/2.
Yep.
8 times 4. Right?
If we want to do 8 times 4, then we got to go back and find this angle.
Which one's for that angle? B, A and B.
A and B, if you use A and B, you're always using the angle that's between the two sides.
So it'd be 5 times 4.
Yeah, so this one would be 5 times 4. Christian, or you want to finish it up?
Christian got it.
Yep.
Sine 125.1.
Sine 125.1. Yep. So the only extra step, we had to take a little time to find that angle, so it probably takes an extra minute to get that done. But let's go through it. 5 times 4 is how much? 20, and then half of that is 10 sine 125.1. So we got 10 sine 125.1. So we get an area of 8.18. Do we have a label? Yes, we do. So what should be my label on 8.18?
B.
feet squared. 8.18 square feet. Okay. Any questions on that one? All right, so when they give you side, 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 you can still use this formula, and it works fine, and that is the correct answer. But there's an easier way. When you have all three sides, there's a way that's faster than what we just did. So I'm going to show you what I think is a better way. And this is known as Heron's formula. Okay, so this is an easier way to find the area of a triangle when you know all three sides. Do you have to use Heron's formula? Nope. We just did the problem with all three sides and we didn't use Heron's formula at all. So you can do it the way I just showed you, or you could use this formula. It's the square root of, and then it's four things multiplied together. S times S minus every side. S minus A, S minus B, S minus C. So we know what A, B, and C are. Those are the sides. Have we seen S before? No. So S, it's a little hard to guess what that would stand for. But A, B, and C, again, those are the lengths of the sides. S is the semi-perimeter. What do you think that means? Semi-perimeter. Not the perimeter. Semi-perimeter. Yeah?
Half of the perimeter.
Half of the perimeter. So just add up all the sides and then take half of it. So what we're going to do is we're going to go back and do the same problem we just did. We'll find the area of the side-side-side triangle and see if we get the same answer using this formula as we did using law of cosines. Now, if we used law of cosines to do it before, and this is a new formula to find the area of a side-side-side triangle, to prove this, you would use law of cosines somehow. All right. If you were going to go through the proof and figure out where does this formula come from, it would involve law of cosines. But it's quite a bit longer than the first formula proof, and it's a little tricky, so it's not really worth going through it for us.
Will this ever end up being a negative or not?
No, it'll never be a negative. No, because if you add up all the sides in a triangle and you take half of it, it's always bigger than any side. Yeah, it's always bigger than any side. We could prove that. We could prove that the semi-perimeter is always bigger than any individual side, because if it wasn't, you'd end up with a negative, and that's a problem. But you won't. Okay, so let's take a look at, I think it's the same example we just did. 4, 5, 7, let me just go back for a second. Yep, 4, 5, that's 4, 5, 8. You know what, let's make it 4, 5, 8. That way it's the same problem we just did. Oh, that's also the same. I'll change the next one after. But let's do this one, 4, 5, 8. All right, so if we want to find the area, what's the one other thing I have to find here to use Heron's formula? I'm missing something. Yep.
You need the perimeter, or the semi-perimeter.
Yep, I need the semi-perimeter. So we're going to take half of 4 plus 5 plus 8. Right, what's 4 plus 5 plus 8? 17, and half of 17 gives me 8.5. Okay. So now I've got A, B, C, and S. So now we'll fill in those four things into the formula. So it's the square root of S times S minus every side. So the area is the square root of S times, and Joe, what's going to go in the first parenthesis?
8.5 minus 4.
Yep. So 8.5 minus 4. Eric, the second one?
8.5 minus 5.
Yep, 8.5 minus 5. And Corey, the last one?
8.5 minus 8.
Yep, 8.5 minus 8. So if you look, none of those are going to come out negative.
Will any of them ever come out negative, or will they
No.
always be bigger?
They'll always be positive. What I like to do is just do those 3 first before we type it in, but then we'll need our calculator. Christian, what's 8.5 minus 4?
3.5.
8.5 minus 5, the next one will be 3.5.
4.5.
4.5, yep. And then we got the 8.5 minus 5, we just did that. How about 8.5 minus 8? 0.5. Okay, and now we'll type that in and see what we get. But we already know what we should get. We should get 8.18 because we're doing the same problem. Okay, so let's turn it on. Take the square root of 8.5 times 4.5 times 3.5 times 1/2. Right? And we get almost the same answer, not quite. Why is that answer a little different? There's a reason. This is the exact answer, what we just did. That is correct. I mean, our other one was correct, but there's something happened there that caused it to be a little off. Yep.
When we rounded that 125.1.
Yeah, the angle wasn't 125.1. It was like 125.099. All right, so because we rounded it, messed up the area a little bit. Not that much, right? They're both accurate to like 4 decimal places out. 0.1815, 1815. But then after that, they change a little bit. Right? So the area again is 8.18. Now, this time I don't think they gave us any units. Nope, just 458. Okay. Any question on that one? Yeah.
Wait, so what happens? Okay, can you scroll up, please?
Mm-hmm.
So know how it's 4 plus 5 plus 8? What if it was 4 plus 4 plus 9? Wouldn't that make it? It would make it to the 8.5 is the same unit per meter, but the 9 would be more than the 8.5.
Well, if you had a triangle that was 4, 4, and 9, the sides wouldn't connect.
Why?
Because 4 and 4 is too short. In any triangle, if you add up 2 sides, they have to be bigger than the third.
Oh, okay, that makes sense.
Yeah. So it's called, I think they call it the Triangle Inequality. Any 2 sides in a triangle have to be bigger than the third. So 4, 4, and 9 would look kind of like this. Like 4, 4, and 9. And it would be too short to reach. You couldn't draw it. So if you ever end up with an area or something that comes out negative, it would be because they gave you a triangle that doesn't actually work, but I'm not going to do that. Okay. Any questions on that? All right, so let's try, I'll have you guys try this one on your own. I'm just going to change the numbers a little bit because we just did this. Actually, you know what? I'll let you make up the numbers. But remember, whatever numbers you pick, any 2 sides have to be bigger than the third. So you can pretty much pick anything you want for the first side. It doesn't matter. All right. So Eric, you want to give me a number?
6.
6. So we got 6. Someone else give me another number? 10. Now let's think about the third side a little bit. What's the smallest the third side could be? How big? How about 4.5? Could it be 4.5? It has to be bigger than 4, right? It can't be 4.
Why?
because any two sides added together have to be bigger than the third. If you made it smaller than 4, like if you made it 3, 3 plus 6 is 9, that wouldn't make a triangle. So it has to be bigger than 4, but it also has to be smaller than what number? I mean, like you couldn't make it 1,000. If you made it 1,000, that would be a problem. It's got to be smaller than what?
16.
Right. Any two sides added together have to be bigger than the third. So it has to be smaller than 16. So anything between 4 and 16. So we could pick 7. That works fine. All right. So take a second to set up your formula and see if you can at least get to the point where you've got your formula ready to type in. And if you have a calculator, go ahead and type in. All right, so we're finding area of this triangle, but what do we need first? Yep.
So we need the semi-perimeter.
Semi-perimeter. So let's add them all up. 6 and 10 is 16. 16 plus 7 gives me
23.
23. And I need half of it. It's easier to usually put it as a decimal.
11.5.
Wait, why are you dividing?
Because that's semi-perimeter. Half. Or you can multiply by a half. Multiply by a half or divide by 2. It's the same thing.
So 11.5.
So that's my semi-perimeter. Now, what's going to be my formula to find the area? What do I put first? Well, I put first the square root. After that, yep.
11.5.
Yep.
And then in parentheses, 11.5 minus 6.
Okay, let's do it. What's 11 and a half minus 6? 5 and a half. All right, next one. 11 and a half minus 7. Yep, 4 and a half. And the last one, 11 and a half minus 10. 1 and a half. Okay, so let's see, we know we're going to have a label. We're going to have square feet. And let's see what we got. So square root of 11 and a half. Let's try again. Times 5 and a half. Times 4 and a half. Times 1 and a half. The order doesn't matter. Okay, because you're multiplying everything together. So just put it all in, and you should get 20.66 square feet. Any questions on that one? Yeah.
Were you recording that whole conversation about barcodes?
No, we did not. We left the barcodes out of it.
How do you use the barcodes?
Hey, did you go to like school for it?
How do you get like 5.5?
5.5?
Yep.
So we did the semi-perimeter
Yep.
minus 6. So
Oh,
11 and a
okay.
half minus 6, 11 and a half minus 7, 11 and a half minus 10.
Okay.
It's S minus every side. Doesn't matter which side you call A, B, or C.
Alright.
All right. So what I want to do now is I want to come up with a special formula for a special kind of triangle, and that's an equilateral triangle. So we're going to come up with a formula that will give us the area of an equilateral triangle. What does that mean if it's equilateral? Yep.
All sides and angles.
All the sides and angles, all the sides are the same, all the angles are the same. So if all sides are the same, if I pick a letter for one side, let's pick X. What does that mean the other sides would be? They're all X. Now, side, side, side. We can use Heron's formula to find the area. The only difference is going to be, it's going to be all letters. We're not going to have any numbers to plug in. So let's start with the semi-perimeter. Okay. What's the perimeter of that triangle? 3x. And half of that would be 1.5x. Or if you want to leave it as a fraction, that I don't know if that's easier, it's just 3 over 2. Either way. It's 1.5x. Okay. So now let's write our formula for the area. So it's the square root of, what's the first thing that I put? 1.5x.
Wait, where did you get the 3 and the 2 from?
3 over 2 is 1.5. That's the semi-perimeter.
Yeah, but
You should do 1.5.
I'm going to leave it as a fraction because it's something that's going to happen in a
Yeah,
second.
but we got x's. Where do you get 3 and the 2?
So 1x plus 1x plus 1x is 3x.
Oh.
And then half of it is 3 over 2x.
That's how you get the top? Did you just add them all together?
That's how you get the semi-perimeter. Yep. And then, what comes next? 3.5x, yep.
Minus 1.
Minus 1x. And then the next one?
It's the same.
Same thing. And the next one?
Same thing.
Same thing again. All right, so we can simplify what's in those parentheses a little bit. Well, you think of it as 1.5x minus 1x. Half x. And again, I'm going to leave it as a half, not 0.5, because you'll see something that happens. What about the next one? Another half x. And the next one? Another half x. Now, we're multiplying 8 things together. 3 halves, or 1.5, times x, times a half, times x, times a half, times x, times a half, times x. Since you're multiplying everything together, you can put it in any order you want. It would make more sense if we put all the numbers together and all the letters together. Why put a letter between every number? That gets confusing. So let's just write it like this. 3 halves times a half, times a half, times a half. Put all your numbers together. And then we can do that. And then an x times an x times an x times an x. And we can do that as well. All right, so multiply straight across the top. 3 times 1 times 1 times 1. 3. 2 times 2 times 2 times 2. 16. And then x times x times x times x.
X to the 4th.
X to the 4th. Okay. And we're just about there. We can just simplify that a little bit. When we take the square root, we do each one of those 3 things separate. Square root of 3, square root of 16, square root of x to the 4th. 2 out of 3 of those will simplify. The square root of 3 doesn't. That just kind of stays the same. How about the square root of 16? 4, because 4 times itself is 16. And how about the square root of x to the 4th?
Square root to the 2nd.
Square root of 2 is 2nd.
Well, when you take the square root, it's going to be gone. Just like it's gone with the 4.
X to the second.
It's just x to the 2nd. Because x to the 2nd times itself is x to the 4th. And there it is. That's the formula to find the area of an equilateral triangle. Square root of 3 over 4 times x squared. Just remember, x is the length of the side. Now, you don't need that. You could just use Heron's formula. But if you have an equilateral triangle and you use Heron's formula, you're going to be doing the same calculation 3 times in a row. So rather than repeating all that work, we'll stick with that. So we'll try an example.
So if you literally had an equilateral triangle and say like x is 3, you can just
Or 8.
plug it in and then you don't have to do the rest of it.
Yeah. If you plug in 8 into this formula, that's it. That will be the answer for the area of the triangle. Now the reason the formula is so short is because this is a special triangle. It's equilateral. All the sides are the same. Okay? So in example 6, what am I plugging in?
8.
8. Plug in 8 for the length of the side. So what's the formula going to look like if I do that? Well, what doesn't change? Square root of 3, yep.
Over 4.
Over 4 times
8 squared.
8 squared. So we just do that out and see what we get. Square root of 3 over 4 times, you could put 64 if you want to put it over 1, you can. And then 4 goes into 64. How many times? 16. Yep. So all you're left with is the square root of 3 times 16, which we normally write this way. 16 square root of 3. And what was that length? 8? We don't know. So 16 square root of 3 units squared. If they wanted you to do it out, you could just type it in and see what you got. So which formula do you think is more useful? Heron's formula or the formula we just came up with?
Both.
All right. Both? Both just as useful?
Depends what kind of triangle.
Wait, so wait. Yeah, aren't they both good formulas to use, but one's for an equilateral and one's not?
Well, yeah, one is specifically for an equilateral, so which one do you think is more useful in general?
That one.
The Heron one.
Heron's, right? Heron's formula you can use on anything. This is a very special formula. It only works on equilaterals. But it's short. But you can't use it in as many places. Right? So, I mean, we could come up with formulas for every kind of triangle. We could come up with one for an isosceles. We could come up with one for equilateral. We could come up with one, you know, if the angles are 30, 60, 90. I mean, you can come up with formulas all day. But that's the only special one that I want to do. All right, so the last thing I want to show you, like the last 5 minutes of this lesson, is just kind of a preview of what's coming up for the rest of the week. So, does anybody remember when we talked about sine, cosine, and tangent? Sine was equal to a letter, cosine was equal to a letter, and tangent was equal to a letter. Does anyone remember what those letters were when we did the unit circle? Yeah?
Wasn't it sine was alpha?
Well, the letters are going to be x's and y's. They're all x's and y's. Yep.
Isn't sine y?
Yep. Sine was y. What about cosine? Cosine was x. And now tangent was a fraction.
Y over x.
It was y over x. Now, I want you to look at what he just said. Sine is y, cosine is x, tangent is y over x. What did he just say y was? Y is sine. What did he say x was? Cosine. So look what we really have. Tangent equals sine over cosine. That's a trig identity. If you want to know the tangent of something, you can take the sine and divide by the cosine. So let's say you wanted to know the tangent of 15. And your calculator, for some reason, tangent button wasn't working. Well, you don't need the tangent button. It's a little longer, but you could type it in as sine of 15 divided by cosine of 15, and it will always give you the tangent. It's a special formula. So now, let's say you had something like this. Tangent times cosine. These are the kind of problems we're gonna look at for the rest of the week. Well, tangent times cosine. That's a trig expression, but that's kind of complicated. It's complicated because you got two of them, and you're multiplying them together. Well, there's a way to simplify that. What did we just say up above tangent was equal to? Tangent is sine over cosine. Now, cosine is not a fraction, but if you want to make it 1, you can always put it over what number? 1. Now, when you multiply those fractions together, it's just like multiplying something like this. What would happen when you multiply 3/5 times 5 over 1?
The 5s would cancel.
The 5s would cancel out because you have 1 in the top, 1 in the bottom. So what's going to happen here?
Cosines cancel.
The cosines cancel out, and all I'm left with is sine in the top, 1 in the bottom, which is just sine. So if you asked me to do something with tangent times cosine, I would say, well, I have a simpler way to do it. Instead of taking the tangent times the cosine, I could just do the sine. It's exactly the same thing. So that's the kind of stuff we're going to look at for the rest of the week. Taking something that looks complicated and try to make it simpler. They're not always that simple. That's probably an easy one. They get a little harder, but that's the idea for the rest of the week. Right. And what I'm going to do is split the test up. So half the test is going to be on what you learned today, and half the test will be on what we do the rest of the week, because this stuff is quite a bit harder. So if I put a lot of the area of the triangle stuff on the test, that kind of helps a little bit because it's easier. Okay. Questions?
Oh, I was just gonna ask if both these things are gonna be on the same test.
Yep. So it's going to be 2 separate things. The test will probably be like 16 or 17 questions. I would say 8 or 9 of the questions will be on what we did today. And then like 6 or 7 questions will be on what we learned the rest of the week.
I just take like that the Monday part of the test like right now while it's like fresh and spicy in my brain.
Yeah.
Monday, I don't have it yet. I don't have it made yet.
It's like my brain's ready to go. It's ready to rock out by Friday. It's gonna be like.
All right, so the homework tonight is page 280, 6 to 16, just the evens, and then 20, 22, and 33. I'm giving you a hint for number 33. Number 33, they want you to find the area of this section in blue. That's the goal. They want to know the area of that little section in blue. Well, that's kind of a weird shape. We don't really have a formula to do it. But what we do have a formula for is to find the area in red. That's what we did very first week. The area in green, which is a triangle, that's what we did today. And if you take the area in red and you subtract the area in green, you're left with that little section in blue. So that's a hint for how you do number 33. But you're going to have to go back and look up the formula for that. That's called a sector. That's area of a sector.
Why don't you just tell us?
Then it wouldn't be as fun.
It'll be fun for us.
Fun for you.